So, shape generator. So what is shape generator? So shape generator is a topology optimization tool in Autodesk Inventor, which the function of this that it can help you figure out the best possible shape for a part based on how it will be used. That means taking into account where it's fixed, where what load it faces, and what you want to optimize it for. It's particularly useful in concept phase of the design where you're trying to develop parts that are both strong and efficient. So if you know how to use this feature, it will be very useful because instead of trying to optimize things by yourself, you can use AI to optimize the part. So why use shape generator? There are several great reasons to use shape generator. First, it helps reduce the amount of material you use, which can lead to cost savings, especially if you use it at scale. It also helps you create lighter parts, which is crucial in industries like automotive and aerospace. Plus, it often suggests organic, non-traditional shapes that can inspire you to think differently about how you design parts. So here is the general workflow overview when using shape generator. You start with the basic 3D model of the part you want to optimize. So from there, you can apply constraints such as, for example, your what do you call it, your screw holes or maybe parts where you don't want it to move. And also the loads, basically where the part is gonna experience forces from the outside, for example, maybe pressure loads or standard force loads. And then from there, you define preserved regions and obstacles. Preserved regions are parts of the object, the model where you want to keep it. For example, maybe just now we were talking about the screw holes. Obviously, the mounting screw holes are where you mount your parts to other parts. So we want to keep it. We don't want the AI to remove those parts. So we can use the preserve regions function to make sure that it doesn't go away, it doesn't move. And also different types of obstacles, yeah, parts that you don't want to be removed. And then from there, you reduce your mass or optimize the stiffness. Set a target. Yeah. For example, usually you want to use shape generator to reduce the weight of the parts, right? So this is where you tell the AI specifically by how much you want to reduce the mass of the part. Like for example, maybe some parts you want to reduce the weight by 30%, so you can define it here. And then from there, run shape generator. After you, once you set everything, the computer will calculate the best mesh to hit those targets. But of course, these are not be all and all. We're just gonna use this to guide the final part of your design. So next, key requirements. These are the targets you should aspire to reach so that you can use shape generator the best that it could be. So, one of the first thing you need to do is make sure it is a single solid body, because the way shape generator uses is that way it's basically similar to finite element analysis, and so It is preferable that you do it all in a single solid body, or else the computer is gonna have a hard time to calculate all the meshes. And then next, apply valid constraints and loads before running the tool. So if, let's say, for example, you have a mounting hole, make sure you apply pin types of constraint instead of, say, bearing type. And maybe if you do have a bearing, make sure you apply bearing to it. And then next, yeah, define obstacles. Make make sure, for example, if you have a, what do you call, you have a bracket where you want to use it to support a system, make sure those parts of the obstacles we define it, we use preserve regions on it. And then next, only supports static load cases. This is also part of the limitations of finite element analysis in normal inventors. So basically what that means is that we can't really use shape generator for parts that we want to, what do you call, optimize around, say, thermal loads, or around, what do you call that? Thermal loads or dynamic loads or just time-based scenarios. So these are the things you have to keep in mind and make sure you model your parts around these limitations. So next, I will be talking about tips and best practices. These are the things that you can do in order to accelerate your shape generator. You can do it to make sure the part, the AI calculates the meshes a lot faster, or we can get better results out of it. So the first thing you have to do is simplify the model before optimization. Basically, this is all like I mentioned just now. Limitations with FEA, we try not to use it for parts that are way too complicated. It's gonna take a really long time on your PC. Even when you have a really powerful PC, it may take a long while. Or yeah. Also, once the calculations do finish, it may cause problems in terms of accuracy of the calculations. And then next, use symmetry for balanced designs. For example, let's say you have a part that's irregular in shape. It's preferable that you use symmetry. So next, make sure the mesh size is appropriate for accuracy and performance. Basically, in FEA, the computer will put meshes all around the surface of your part. So because of that, the accuracy of the study, we can define it by how fine the meshes are. So if you do have a really powerful computer, you can make the mesh size very fine. However, it will take a long time. So if your computer is maybe not as fast, or you need the results fast, like right now fast, maybe you can increase the mesh size. However, do keep in mind that if you do increase the mesh size, it may cause the calculations to not be as accurate. And then next, the most important thing is review the results critically. This This tool is not the be all and all when it comes to design. At the end of the day, it's always better to validate it with an actual practicing engineer, because maybe we have certain parts that we may have overlooked. And so that's where an engineer's eyes will be able to see through it, and may will see through it and double confirm it. Okay, someone says enter. So here are the limitations when it comes to part generator. It only works on single parts, not assemblies. So this is a very big one. So if let's say you do have an assembly, let's say you have a assembly of a uh, what do you call it? Of a suspension system, for example, in a car, and you want to optimize a bracket that's holding your roll bar or maybe your wishbones. So when you have those types of scenario, make sure you select just the brackets and do the shape generator on it. And then next, it supports only linear analysis loads. So no dynamic loads. This is a limitation with FEA in normal inventor, but don't worry. So once you do have an optimized shape, you still need to post-process it into solids so that if, for example, you have a bracket that you just finished optimizing for, you still need to post-process it. You still need to draw it out, all the parts that's gonna be removed and remove it from there. And of course, since it is not a solid, it's still not a solid, you can't just directly export mesh to 3D printers. Okay, here are some real-world applications for you guys to get ideas on where you can use shape generator. So in automotive, for example, you can use it in lightweight structural brackets. For example, just now I give you when it comes to, for example, we can use it in suspension assemblies or maybe even throughout the chassis parts where you may not necessarily need the extra strength there. So maybe we can remove those parts there. And then, yeah, doors, we can use it on doors because usually doors are not structures, so we can remove as much materials from there. However, you still need it to be strong enough to pass certain safety standards. And then next is aerospace. When the applications is quite similar to automotive, where in aerospace you can use it to optimize frames and supports. In aerospace, it is being lightweight is very crucial because the more weight you have, the more energy you have to spend in order to make the airplane fly. So it's very obvious that we can use this here. And then next, consumer products. For consumer products, for example, maybe you can take spoons or even knives. So in consumer products, in general, we want to make sure it's not really from the angle of lightweight, it's more so the angle of saving as much material as possible so that it can stay as affordable as possible. So using shape generator, we can parts, remove areas of those, for example, a spoon where it's not really necessary. So we can reduce the waste there and reduce costs for consumers. And then next, industrial machineries. When you have industrial machineries, you can use shape generator to make the parts, for example, brackets on a, what do you call that? On a machine, you can use it on brackets on the machines so that you can better optimize the load distribution from the machines. For example, let's say maybe the machine is heavy, so you can use shape generator to distribute the load evenly without without compromising the strength. So that's all for my slides. Get to let's get to demonstration on Inventor. So let me share my Inventor. Okay, here we go. So this is what you usually see when you open a part in Inventor. So where can we find the shape generator function? It's just over here beside modify. However, do know that sometimes you may not see it here. So how do we make sure that it's here? Just click on this part. For example, if this doesn't just apply to this, let's say you have other parts and it went missing, so you can just click here. And then you can just click on, I believe it's explore. Yeah. Make sure that explore is enabled over here. And so that should give you the shape generator function over here. So just click on it and just click OK. Yeah, there we go. So first thing you have to do is create a study. This is for later. Assign the material for the part, obviously. So here I'm just gonna go to materials. You can click on materials, and from here you can select all the different types of materials. For example, here you can use any materials really, but let's say I'm gonna use steel. Sure, steel. Let's go for stainless steel. Just click here and make sure it's selected. Okay, there we go. Yeah, now it says stainless steel, and that's correct. Okay, we've done that. And then from there, we just select we define our constraints. For example, here, as you can see, this part, for maybe I want to have the force coming from this direction, which will then translate all around here. And then we have our pin around here. So here, just select pin, select this surface, because this is where our supports will be. Click apply, and then just click apply. Yeah, there we go. So here are different types of constraint. You have fixed and then you have pin. Usually when it comes to mounting holes, you want it to be pin. Fix is mostly, for example, in buildings, you have your brackets which are attached to the wall. You can use fix. And then from there, you can select different types of load. I'm gonna select force. Select, we're gonna have the force coming in this direction, and for magnitude, I'm gonna make it 100 newtons. Yeah, I do know that here, for example, here it says the force is in pounds. However, if you just put Newton, you put N like that, it's gonna be as 500 Newton regardless. Yes, so it's auto converts it. And then we're done with that. Let's go to our preserve region. These are the different types of boxes you can use. Usually we're just gonna use boxes. So just click here. Yes. And then just maximize it. Obviously, we don't want this part to be removed. So we're gonna preserve this region and make it as big as we want it to be. Let's, yeah, make sure that it's covered. That's done. So next, we can go here. Yeah, view it from here, from the top, so we can see more clearly. Okay, there we go. And then this area, we don't want this area to be removed. Oh, make sure it goes in the right direction. And then next, it's gonna be this area. So region. We don't want to really preserve the entire thing, so let's just reduce it to maybe this much. Now we go apply. Yeah. So we're done with that. Let's create shape generator settings. This is where you can set your targets. For example, maybe you want to remove the original by 60. I'm gonna go down to 50. And this is where you can select your mesh size. I'm just gonna go to 3. It should be fine. Most should be sufficient for our study today. So next, we're done with all that. Let's just click on generate shape. Yeah, just click on one. Yeah, it's gonna take a little while. If something's wrong here, let me just cancel that, do it again. Maybe it's my constraints a bit off. Let me just do my constraints again. Let's just reduce the mesh size because we don't have much time. Choose facing the color. Okay, there we go. Let me try that again. Okay, everything's right. I think maybe the paint is a bit weird. Let's try it on the inside. Should be on the outside, but it doesn't work. Let's Okay, there we go. It just takes a little bit of time. So we can see here it takes a little bit too much. Some parts are disconnected. However, well, what you can do here, maybe you can just you can re-edit all the preserved regions. However, we can also just use the part as is. So let's say, for example, you are fine with how the shape turns out. Just click on promote, click on part file. Okay, promote successful. And then from here, as you can see, it's not in 3D shape. So from there, this is where the extra part we have to create 2D sketch on goes. So from here we can just use this as a guideline. So from here, for example, so we can just use this as guideline to know where we can draw to remove parts. So this part, I think I'm just gonna keep this area. Maybe we can go a little bit here. Don't we don't have to take all of it. I think this part is a little bit aggressive, so maybe we can just remove here. Yeah, there we go. Make sure it's closed. So from there, you draw the areas one to remove. From there, you can just extrude it. Make sure it's going in the right direction. Yeah, there we go. And remove it from there. So we have our part. So from there, we can use, where is it? Okay, you can do stress analysis to see whether or not your part that you made is okay. So you don't have to redo everything when it comes to constraints and force and such. You can just create study here, static analysis, and click on OK. So from there, just click on simulate. Hold on, do look define. Oh, sorry. We have to put again all of our constraints. So here is spin, apply, apply. There we go. And then pause. This one is 500 newtons. Yeah, there we go. So now we should be able to simulate it. Yes, and it runs fine. Okay, so we're done with simulation. So here, as we can see the different types of stresses that we put it through. However, the most real important here is the safety factor. Usually you want your safety factor to be maybe around 1.5 to 2. So from here you can see some some parts is experiencing too much force, so the safety factor is a little bit too low at 0.45. What this means is that it cannot handle the load that we specified, which is 500 newtons. So from here, what you can do is maybe you can increase the parts, the materials around this part. Let me just do that. You can just go here and change the sketch. Maybe we can increase this part a little bit. So, yes. So go back to environments, trace analysis. Yes, we've done everything. Let's just simulate it again. As you can see here, the safety factor around this area has been improved to 0.5. So we can, so Here you can just keep on trying to do it again and again to make sure the safety factor is as high as possible. I'm just gonna stop here because we don't have any more time. And so that finishes my demonstration of this part. Before we go, let me just talk about my company's website. Uh, so here's our company's website, icadsystems.com. So here is our phone numbers for our different offices, one in KL and one in Penang. So for example, if you want to contact me, you can contact the KL office. And then next, this is our latest promotions and news. Everything goes here. So for example, let's say you want to buy AutoCAD, maybe AutoCAD Lite, you can just check out this area and see if there's any discounts or promotions, which so you can get the softwares for cheaper. And then from there, this is our list for FOL courses. Let's say if you are interested in any of our upcoming future free classes, you can just click here and then just click on RSVP. What this does is mostly just sends out an email to you whenever the class is almost here. So next, you can go on to our YouTube, youtube.com. Let's go to Acad Systems. So this is our YouTube channel. This is where you can watch all of our previous, for example, of our previous classes. We can go, oh, sorry. You can go online. This is where we post all of our previous online classes. As we know, we do it here for free and we stream it to YouTube too. Just click on search and you can search for any classes that you're interested in. For example, Inventor. Here you can see the different classes we've done before. And so I think that's it from me. Yes. Thank you so much for joining, and I'll see you guys for our